Okay, today we're going to do 1.6 part 2, which is performing with complex numbers, performing operations. We learned in part 1 that an I stood for an imaginary number, which is a negative under a radical sign. This section, or this part, you're going to find out that when you get an I squared, it automatically becomes a negative 1. The good news is all the operations that you're going to do in this problem, distributive property, FOIL, anything like that, it's still going to be the same, except wherever an I squared comes in, there's a negative 1. All right, let's take a look at this. Example number 3, multiplying complex numbers. Write the expression as a complex number in standard form. So you're just going to go ahead and multiply or distribute like you normally would. So 4i times negative 6 would give you negative 24i. And then 4i times I is a positive 4i squared. However, you're not done, because remember, wherever there is a negative 1, it becomes, wherever there's an I squared, it becomes a negative 1. Now remember, this is 4 times I squared. So now this becomes negative, this is the long version, negative 24I plus 4 times negative 1. Negative 1 times 4 becomes negative 24I minus 4. But recall, back up here it says in standard form. So if you remember, in standard form, the real part of the number comes first, the imaginary. Because remember, standard form is A plus or minus BI, remember that? So this is your imaginary, this is your real. So for this to be in the correct standard form, you would have negative 4 minus 24I. And that's actually your final answer. So here, same thing, you're going to distribute. 2i times 4 is 8i. 2i times I is 2i squared. I squared turns into a negative 1, which causes this to become 8i minus 2. The real part goes first, the imaginary part goes second, and you are finished. All right, now when you look at this one, depending on how comfortable you guys are, this could be FOIL, or you could do this using the box method. Now you'll learn that I always do this using the box method, because later in the year when we do polynomials, like trinomials times trinomials, it gets a little crazy. So the boxes actually help you. So I always go to the box method. It keeps things neater. So this is a binomial times a binomial. That means you're going to need 4 boxes, a 2 by 2. Okay, make sure you have room to write. So you're going to put the first one, doesn't matter if it goes across the top or down the side, doesn't matter what order, negative 4 and 7i. Come out. 9 times negative 4 is negative 36. Negative 4 times negative 2i is positive 8i. 9 times 7i is 63i. And negative 2i times 7i is negative 14i squared. Okay, now be careful, because remember, I squared becomes negative 1. So negative 14 times negative 1, this entire box actually becomes positive 14. Okay, so I just kind of got rid of all that, so that way you can see that's a positive 14. Now look at your diagonals, because your diagonals will now combine. Remember, real number comes first, so you're going to do negative 36 plus 14. So you're going to get negative 22, and then 63i plus 8i is going to be plus 71i, and that's going to be your final answer. That should be a 71, sorry, nice and messy. There you go. Okay, now go to D. Okay, again, it's a binomial times a binomial, so I'm going to do my boxes. Okay, across the top, 8 minus 3i plus 2i. Going to multiply. 2 times 8 gives you 16. 2 times negative 3i is negative 6i. 8 times 2 is 16i. And then negative 3i times 2i is negative 6i squared. But remember, I squared becomes a negative 1, which multiplies times the 6, so it basically just makes it a positive 6. Check your diagonals. 16 plus 6 is going to give you a 22. 16i and a negative 6 is going to give you a positive 10i, because this is standard form, a plus bi. Real part, imaginary part. And there's your answer. Okay, I just gave you 2 here. Shouldn't be too difficult for you, hopefully. Biggest thing is remember that the I squared equals -1. Okay, go ahead and hit pause and work this problem out, and when you're ready, hit play. All right, distributive property problem. 3i times 8 is 24i. 3i times 4i is positive 12i squared. I squared becomes -1, causing this to be a negative because of the multiplication. Okay, so 24i minus 12, but remember you should always write your answer in standard form, so it should actually be -12 plus 24i. There's your final answer. Okay. Number 2, go ahead, hit pause, work it out. When you're ready, hit play. Okay, draw your boxes out. 3 and 3i, and 5 and 5i. So 15, this is 15i, this is 15i, both are positive, and then this one is going to be 15i squared. 15i squared turns to a -1, which causes this positive 15 to become negative, so that's actually the only number in there. Check your answers. Positive 15 and -15, they just cancel each other. Then you have 15i and 15i, and that's going to be 30i. So this only has an imaginary part. All right, good job. All right, now let's look at the next one. This is that complex conjugate thing that we talked about earlier in the chapters, to where you have to multiply by the opposite. Although it says divide complex numbers, you're really not dividing. You basically can't have an imaginary number in the denominator, so you're multiplying by the complex conjugate. So just like we did the other day, you're going to multiply by the opposite of that sign. So the top is 7 plus 5i, the bottom is 1 minus 4i. So in order to eliminate this, we need basically to make a difference of 2 squares. So you're going to multiply 1 plus 4i and 1 plus 4i. Now, these are both binomials, so if you're a box person, you're going to do 2 of those. Okay, for those of you who understand the point of a complex conjugate, that the 2 middle terms cancel, you can just multiply these together and these together. So what happens is when you multiply that bottom together, you're going to get I times I, which is, or excuse me, 1 times 1, which is 1. Then you're going to get -4 times positive, -4i times positive 4a is -16i squared. I squared turns to a -1 and causes this to be a positive 16, which gives you 17 on the bottom. Now, if you're not quite sure what I did right there, go ahead and do your box. It would just be a box, and I'm here, 1 minus 4i and 1 plus 4i. And when you end up with it, you're going to get -16i squared. But what happens is these 2 middle terms are automatically opposites of one another. That's the point of the complex conjugate. So if the complex conjugate gets rid of the middle terms. So I know that, so I only worry about my firsts and my lasts. And then this becomes a positive 1 plus 16, which is what you had here. Now the top is not so easy. You actually do need to multiply those out. So the top of this is going to be another set of boxes because, again, it is a binomial. So you're going to do 7 plus 5i and 1 plus 4i. Remember, you can have i's in the top and not in the bottom. 1 plus 7 is 7. 5i times 1 is 5i. 7 times 4i is 28i. 5i times 4i is 20i squared. It's positive 20i squared. This turns to a -1. Multiply that times 20, so it turns into a negative. Now check your diagonals. 7 minus 20 gives you -13. That's your real part. 28i plus 5i is positive 33i. So the top of this is -13 plus 33i. There you go. Okay. That one's the more tricky one. It's not hard, it's just a little more challenging because you have conjugate. The nice part is it's the same rules with radicals. No radicals in the denominator, no i's in the denominator, so multiply by the. All right, go down to f. Again, you're going to go the opposite of that. So 7i over 2 plus 3i. You need the opposite, 2 minus 3i times 2 minus 3i. Now, again, these are complex conjugates. So the two middle terms are going to cancel, or those looking at your boxes, your two diagonal boxes are going to cancel. So save yourself a little work. Multiply the first ones together and multiply the last ones together. So 2 times 2 is 4. Positive 3i and negative 3i is negative 9i. But remember, I squared is negative 1. So negative 1 times negative 9 makes it a positive 9, which causes the bottom of this equation to be a 13. All of that work is only the bottom. Now on the top, this one's just a distributive property problem. You're going to do 7i times 2. That's going to be 14i. 7i times negative 3i is negative 21i squared. I squared becomes a negative 1, gets multiplied by negative 21, which causes it to become a positive 21. Basically a sign change. But remember, your final answer should always be in standard form. So the answer is going to be 21 plus 14i. That's your final answer. Okay, 2 quick ones. It's because the concept's there. You just have to make sure you do it. All right, now number 3 for you. Your turn. Go ahead and you multiply by the complex conjugate. Hit pause. Hit play when you're ready. All right. Complex conjugate of this is, if you're going to rewrite your problem, at least I need to because it's too small, over 3 minus 2i. So complex conjugate is 3 plus 2i, and the top is, what you do to the bottom, you do to the top. And again, these are complex conjugates, so just do your firsts and your lasts. So the result on the bottom is going to be 9 minus 4i squared. I squared turns to a negative 1, which causes this to become a plus, so the bottom of this is purely just going to be 13. Now, top's a little bit harder. You're going to do your boxes if that's how you do it, or you can FOIL. So 5 and 2i, again, it doesn't matter the order, and 2i. So you're going to get 5 and 3 is 15. This box should say 6i. This box should say 10i. And this box should be 4i squared. 4i squared turns to negative 1. When you multiply it times a positive 4, it becomes a negative 4. So what do you have? You have 15 minus 4. So on the top, you have 15 minus 4, which would be 11. And then 6i and 10i is 16i. Now that's in the order that you need it, a plus bi. So 11 plus 16i is your final answer. If you got it, good job. All right, go to number 4. Hit pause when you're ready. All right, this one's a little different. Remember, to get rid of a radical in the denominator when it's a single term, you just multiply it times itself. So this one, you really didn't need to change the answer. If you multiplied by a negative 6i, you won't be wrong because it'll take care of the problem on its own. But you only need to actually multiply by 6i, and you would not multiply by 6i. Because remember, what you have to do is get rid of the I squared, or get the I squared. So when you do 6 times 6, you're going to get 36, and I times I is I squared. So there you go. You got 36I squared. So this is going to cancel, become a negative 1 times a positive 36 equals negative 36. Okay? All right, at the top, it's a distributive property problem. It's just in a little bit different order than you're used to, so I'm going to go ahead and rewrite it. 6 times 7, I is 42i, and 6i times I is 6i squared. The I squared turns to a negative 1, gets multiplied times 6, so it makes this 6 a negative. So putting it in correct order, so at this point this is what you have. But remember, you want it in a plus bi form, real plus imaginary. So negative 6 plus 42i. Now, I'm going to go one step further with this answer, because what happens is there's something with this problem that you may or may not realize, and the answers on the book vary. What you're saying with this problem, I'm just rewriting, it's saying that both of these are being divided by a negative 6. So I would actually look at this and divide and notice that each piece is being divided by negative 36. And what you would have to do is you would need to reduce it to get the actual simplified answer. So this one, both of these are divisible by negative 6. So both of these this becomes 1 over 6. Now, 42 and 36, again, are both divisible by 6. Okay? If you divide them by negative 6, that's fine too. So what happens here is this becomes 7i over negative 6. But you want to put them back together as 1 because they have the same denominator. This answer is not wrong. It's just not mathematically correct. Since they're both being divided by 6, and what we can do is we talked about in class how a positive divided by a negative is a negative. So we could actually, if we wanted to the top of this problem, and it's the same thing. So then when you write it as a single problem, it would be 1 minus 7i over 6. Don't let that get you. If you get to this point right here, I'm happy. In class, I can walk you through and get you to that. That makes it the hard. That's easy to get to once you understand the concept. All right, let's flip it over. Let's talk about plotting complex numbers. We did this very quickly in the first half of this section. So what this is going to be, you'll notice I didn't give you any year turns on this. This is the real. This is the imaginary. So it's just like plotting a point on a typical XY coordinate, except now instead of X and Y, we have real and imaginary. So on the real axis, we're going to go to positive 3. 1, 2, 3. And then on the imaginary axis, we're going to go to negative 2. 1, 2. And that is your point that you're plotting. So so you kind of treat this as the X coordinate and the Y coordinate. Left or right, up or down. So here, this would be left 2, and this would be up 4. So left 2, up 4. And it would be that point right there. Now this one, there is no real. So basically it's 0 minus, so it's 0 on the real and down 2. So there's your coordinate. Very simple, plain cut. If you know how to graph, you should be fine on this. All right, now this section is guessing, could be the hardest part, but if there's just the biggest thing you have to know about this is it's basically the Pythagorean theorem you're doing here. You're trying to find the absolute value of a point on the coordinate. It would be like me saying to you the absolute value of this. But since we go left down, remember absolute value is a point or points distance from 0. So we are actually trying to find the hypotenuse of this triangle, if you would. And if you remember back in geometry, it's a squared plus b squared equals c squared. This is your a, this is your b, and this is your c. So the biggest thing you have to know for just this part is ignoring the I. The I does not count in this problem. So for this particular problem, remember, you're basically doing a squared plus b squared equals c squared. So the a in this problem is negative 4, and the b is positive 3. Ignore the I. So then the absolute value of negative 4 plus 3i. So this would be left, so if we had a coordinate, it would be left 4 down 3, this distance right here. So a squared is negative 4. So negative 4 squared plus 3 squared equals c squared, okay, which would be your absolute value. So this would be 16 plus 9 equals c squared. 25 equals c squared. Then we learned how do you do the opposite of c squared? You're going to find your square root. So c is going to equal 5. Yes, it's plus or negative 5, but we're not going to worry about that there. The only time I'm real concerned about the plus or negative is when it actually affects the answer, which you'll find out when we do quadratic formula in another section or two. All right, a negative 3, b is negative 4. So again, a squared plus b squared equals c squared. You're going to go negative 3 squared plus 4 squared equals c squared. 9 plus 16 equals c squared. You're going to get 25 equals c squared. I know it's the same, square root both sides, and that's going to give you 5 equals c. Absolute value of this point is 5. Now, L is a little different because there is no real, so there is no quote-unquote a. Actually, this is the absolute value of 0 minus 5i, and it might be easier to go ahead and write that. So this is your a and negative 5. So if you need to write it, go ahead, 0 squared, that's your a squared plus b squared equals c squared. So 0 squared is 0 plus, so this would be 25 equals c squared. Look at that. They're all the same. And equals 5. All right. So go ahead and do number 5. Hit pause. When you're done, hit play. All right. A is 5. B is 3. So a squared plus b squared equals c squared. So 5 squared plus 3 squared equals c squared. So 25 plus 9 equals c squared. 34 equals c squared. Square root both sides. Now keep in mind that needs to be simplified. So that's going to be 17 and 2. Well, because 2 and 17 can't be broken down, c squared is just, or excuse me, c is just the square root of 34. Remember, at this point, if radical can be simplified, you need to do it. Okay, go ahead and do number 6 and hit play when you're ready. All right, A is -4, B is 3. So -4 squared, A squared, plus B squared equals C squared. 16, we've seen this before, plus 9 equals C squared. 25 equals C squared, square root both sides, C equals 5. That's your final answer. And at least number 7, go ahead and do that one out. All right, A on this one is just 0, so it's going to be A squared plus 3 squared equals C squared. So 0 squared is 0, so it's just basically 9 equals C squared. You're going to square root both sides. C equals 3, and you're done. Okay. All right, so things that you learned in this lesson are I squared equals -1, and then you also learned how to find the absolute value. That's basically the 2 new things. You already knew how to distribute. You already knew how to find square root. You already knew how to do FOIL. So mostly everything in this lesson you've already done. It's just adding a few extra problems. So make sure that if you have any questions, you can either rewind the video a little bit to go back and see what I did, make little notes to the side of your margin to see if there's any questions that I can answer for you in class. See you soon.